Hi everyone, welcome back. If you were just here a few minutes ago for my last class, if you're just tuning in, welcome to Geography. We're going to be talking about rivers today. I live in Oregon. This is a state of many rivers. We have the mighty Columbia River, forms much of the top border of our state. People that live here in Oregon, we really like to get outside and hike and go look at rivers and the things that are on them, such as waterfalls. I chose a background image. This is a waterfall that is right next to the Columbia River, east of Portland. I've been to this one. It's really pretty there. But yeah, we're going to talk about rivers today. Hi to everyone in the Q&A box. Hi, Alette. Hi, Ian. Hi, Ananya. Hi, Natalie. Natalie says, I was just in your history class, your, our social studies class. Awesome. I'm so glad you're back, Natalie. All right. So we are going to talk about some geography topics today. I wanted to show you guys, first off, a map of the United States. When we think of a map of the United States, we often think about this. And if you're not from the United States, you may still be familiar with this map. When we first think of something that kind of shows our country, the first thing we often think of is all the lines that break up the country, or maybe show where the country separates from the other countries around it. This map, I am well aware, is missing Alaska and Hawaii. Our maps often do that. Sometimes they include them, sometimes they seem to forget about them. This one did. Some of the lines on a map like this are kind of squiggly, and some of you may be able to guess why that is. Many of the lines are straight lines, like between Oregon and California. The bottom border where Oregon connects to California and Nevada is a straight line. But part of the eastern border of Oregon between Oregon and Idaho and part of the northern border between Oregon and Washington are these squiggly lines that go back and forth. And it happens in many other states too. You can see that between California and Arizona. You can see that between Oklahoma and Texas. You can see that between Louisiana and Mississippi and Arkansas and Tennessee and Missouri and Kentucky and all those states. Can anybody guess what is on those dividing lines? What is breaking up those states? If you have a guess, jump in the Q&A box down there at the bottom of your screen and you can write it there. Yeah, one person says those are the borders. Yes. There we go. Adit guesses a river. You are right. Many of the dividing lines between the states of the United States are rivers. Alette guesses hills or mountains. That's a really good guess, Alette. Hills and mountains do often help form some of the borders. But one of the main ways that we decided borders between states and between countries is often bodies of water. They are very natural dividing lines between areas. So they do often get used to break up where, one area is separate from another area. A more common map, another common map besides this one that we often look at is like a road map. Adults are usually more familiar with these than younger people, but the roads that go across the country have to take rivers into account. When you're deciding where to put the roads of a state or a country, it's kind of tough when you have big things in your way, like mountains or rivers. So you have to decide, you're usually trying to find the easiest path between 2 points when you're trying to build a road. So you have to take that into account. But the map that I really want to show you guys and talk about today is this map and other ones like it. This is called a hydrological map. The word hydro, if you've never heard of that before, has to do with water. What this map is showing is rivers in the United States, and it's showing like the little streams and things that feed into those rivers. Just looking at this map, it can be a little bit tough to figure out what's where. The lines on a normal map that show the dividing borders between states don't all perfectly follow where rivers and other natural features are. You can notice some of them, like again, if you look at Oregon and Washington, on the right next to the Pacific Ocean, on the left side of this map, you can see the kind of characteristic shape. I'll go back once so you can see it again. You can see the sort of division between Oregon and Washington because it's divided by a river. You can see that on this river map where those two states are divided. This is a closer up view of Oregon itself. Now, not every single little line that you see here means that there is a river or a stream or a creek there all the time. What these lines do all mean is that if any water did fall there, that's kind of the direction that it would go. On a dry day, maybe it hasn't rained in like a month in the middle of summer, a lot of these smaller lines, you wouldn't find any water there. But like on a rainy day, these are sort of the paths that water would follow to get into the creeks and the streams and the rivers as they find their way through the state. So rivers, how do they work? Well, we have something called the water cycle. And you may have seen this in a science class before or in a science lesson, but all of the water on the earth is constantly moving in a big circle. Over on the right side of this picture, you can see like a big body of water, like an ocean or a lake. The sun, when the sunshine comes down, it kind of heats up the water, it makes some of it evaporate, and you'll see water, that this line going up into the air is water evaporating and going up into the air. As it goes up into high up in the sky, it cools down and it turns into clouds. Clouds are water that is kind of formed together. It's kind of bunching or grouping together. And when enough of it has, grouped together, it falls back out of the sky as rain. You guys probably didn't realize you were going to get a basic science lesson today too. That water, as it falls from the sky as rain, it hits all the natural features of the ground, such as hills and mountains, all the trees, all the things that are sticking up from the earth. And then the water has to decide which way to go. Now, gravity is the scientific property that things are attracted together. The bigger something is, the more it pulls on other things. The earth is a giant object beneath us, so it will naturally pull things down towards it. But now if you have something sticking up like a rock, think of like a rock in your yard or one that you've seen in a forest or something that has a lot of different sides to it. Or in my picture right here, you see this big rock sticking up right here in the background, right there. If you imagine standing on top of that rock, and maybe you had a big jug of water in your hands, and you poured that jug of water right on the top of that rock, the water would try to find the easiest path down the rock to the ground. As gravity pulled on it, the water would always look for the way that it could slide down the rock, that it would go down faster. The water would try to never go up the rock. It wouldn't really be possible. The water can't really think or move on its own, of course. It can only get pulled downwards by gravity. So the path that the water follows down the rock to get to the ground is basically the same thing as any creek, stream, or river that exists in the real world. To show that picture again, as water is falling out of the sky as rain, that water is going to collect together and it's going to bunch up with other droplets of water. And as gravity pulls them downward, they're going to try to they're going to try to get as close as they can to the center of the earth, the center of the gravity that's pulling on them. As all those water droplets come together, that is the definition of a stream or a creek or a river. It's just water trying to get downhill as easy as possible. I'm going to go to the Q&A box really quick. I can see that there are some questions in here. Gerard asks, why are Alaska and Hawaii out of the main country? Gerard, do you mean just in that map, or do you mean like in real life? If you ask again, give me a little bit more information. I'll try to help answer your question. Tanisha says, evaporation, precipitation, condensation. Yes, these are the scientific words for the water cycle. Very good job. Yeah, evaporation is when the water kind of gets heated up and it turns into a gas and goes up in the sky. Condensation is when the water droplets group together. And precipitation just means when they fall out of the sky as rain. It's a good job. Gerard asks, what is the difference between evaporated water and condensed water? So evaporation, again, is the water like in creeks or ponds or lakes or the ocean or wherever. If you left, maybe if you have a dog or a cat and you have a bowl of water outside and you leave it out in the sun and you come back later and the water's all gone, where did it go? The sun heated up the water, turned it into more of like a gas form where the water droplets kind of heat up, they go up into the sky. That's evaporation. Condensing is when they cool down and those water droplets start coming back together. And when they get into a big enough droplet, they fall back out of the sky. Other questions in here? Tanisha asks, will all the webinars of this be about something different? Yes. Each webinar in the geography class will be taking up a different topic. So tune in next time. We'll talk about a different geography subject. Okay, so Gerard's asking, why are Alaska and Hawaii out of the main country in real life and on the map? That's probably a longer question than we have time for today. But to go back to that earlier map of the country, this one shows Alaska and Hawaii. Hawaii is a group of islands that are way off the left side of this map. There's a group of islands out in the Pacific Ocean that became one of the United States states, I think it was only about 60 years ago. Yeah, I think I have that right. It's about 60 years ago, it became a US state, but it's a group of islands out in the Pacific Ocean. Alaska is just a huge section of land that is way up northwest. You have to continue traveling northwest of Washington. You'd have to travel by boat or by land through Canada to get there. Why are they both US states if they're not part of the main part of the country? Well, there's no actual rules that say that part of your country, that your whole country has to all be connected. In fact, there are many countries where the country has a main chunk, but then it has other parts of it that are not connected. I don't have a map ready to show you this, but Russia, for example, most of the country is in one chunk, and then there's part of Russia, you have to travel through some other countries to get there. It's just another piece of Russia is further west than the rest of it. Sometimes, like with Hawaii, some of the parts of a country will be islands that are off the coast of the main part. Next week in geography, I'm actually going to be talking a little bit more about this subject, kind of the shape of the states, how the United States, how a lot of our states got to be where they are, why they look the way they do. It should be a lot of fun. So tune in next week and we'll talk more about that. Let's see, other questions that we have here. Oh, Gerard also asks, did they drift out from the United States before? No, Hawaii, I believe, was formed basically as volcanoes. Yeah, this is also another question. You're asking great questions, but they take a lot more time to answer. But the shortest version I can give is that volcanoes will form sometimes. And Hawaii, I believe, was formed out of volcanoes kind of coming out of the ocean. And then over a long period of time, they had enough sort of land there that people could live there and plants could grow there. But Hawaii, they still have active volcanic parts where there will be lava coming out. Tanisha asks, did Alaska used to be part of Canada? That's another question we could probably take up better next week when we talk about kind of where some of the states came from. But if you'd like, feel free to research that and you could share the answer with us. Where did Alaska come from? Who did it belong to, or what was it part of before it was part of the United States? If you want to find the answer to that, you could share it with the rest of the class. Natalie says that her 4-year-old sister is with her and learning geography. That's really awesome, Natalie. I'm really happy she's with us. She says the sun was just falling down because the fish wanted to be sunny underwater. That is adorable. All right. Okay, cool. To keep on going here. Yeah, so the water cycle. Water heats up and raises out of the ocean or ponds, goes into the air, condenses, it falls down. When it hits the land, it starts traveling downhill. When you have mountains like this, the water as it falls, this peak right here, this mountain peak, the water that falls on the left side of it will go down the left side of the mountain, of course, but the rain that falls on the right side will go down the right side of the mountain. Believe it or not, that water that is going in 2 different directions can end up in very different places. This is a map of the United States again, but the different colors here are trying to show you sort of the different areas of where the water goes in the United States. To focus on the upper left-hand part, just because that's where we are broadcasting here from, all of the white colored rivers here, they all kind of tend to go in the same direction. It's almost like a tree in that each of the smaller, littler parts connects to a bigger part, which connects to an even bigger part, so everything kind of connects together at the end. That biggest trunk is the Columbia River that empties into the Pacific Ocean. Down to the left of the Columbia is like the Willamette River. I'll show you that more in a little bit. But in different areas, like the huge yellow section in the middle of the map, these are all big rivers that are all coming together and they all empty into the Mississippi, which travels down the middle right part of the map, the biggest river in the United States, the Mississippi. What this is showing here is that all this water is always trying to find its path downhill to the sea, because the ocean is, of course, the lowest point. That's why the ocean is there. It's the lowest point that the water can get to. But if you look again at the left side here, where the Rocky Mountains are, when you have these mountains, the water that falls on the left side of the mountain will usually go towards the Pacific Ocean, where the water on the right side will go towards the Atlantic Ocean. You can see that here where you see the dividing line between the white and the yellow, or the red and pink and the yellow. A raindrop falling 10 feet one direction or 10 feet the other can end up thousands of miles apart from the other raindrop. The term for this is, it is the Continental Divide. The red line here that you see going north and south is the main divide of North America. This red line, water that falls to the left of it goes to the Pacific Ocean, where water that falls to the right of the red line tends to go to the Atlantic Ocean or up to the Arctic Ocean, but it goes in a different direction. These other lines that you see here are the other dividing lines. This blue line, the Arctic Divide, water that falls to the north of this line will go up to the Arctic Ocean, where water that falls to the south of that blue line will go to Hudson Bay. The same for the green line, the Laurentian line. Water that falls to the north of the green line goes to Hudson Bay. Water that falls to the south of it will go towards the Atlantic Ocean, the Gulf of Mexico, etc. The Eastern Divide here, there's a small range of mountains on the eastern part of the United States. Water that falls to the right of it will go directly to the Atlantic Ocean, but water that falls to the left of it will all go together to the Mississippi and then down to the Gulf of Mexico. Now, there are some exceptions. You might notice there is this brown squiggly line on the left part of the map here. That is called the Great Basin. Water that falls within that brown line doesn't usually make it to the ocean at all. The Great Basin is part of Oregon. It goes into Idaho. It's most of Nevada, part of Utah, a good chunk of California down to the south. But raindrops that fall in that area, because of the shape of the mountains around it, water there will usually go into a lake or a pond or a marsh or a swamp or something, and then it will evaporate again. Raindrops that evaporate there might condense and fall back down, and you could have a raindrop that could spend hundreds of years just cycling up and down and never actually make it back to the ocean at all. Here's a map of a sign that you could see in, I think this is in Colorado, but this is showing that right here, you could see snow on the left-hand side in the background and snow on the right-hand side. But that snow on the right-hand side, when it melts, it's going to go to the Pacific Ocean. This sign, of course, you would probably be looking south. You're standing here looking at a sign that is to the south of you, so the Pacific Ocean is on your right and the Atlantic Ocean is on your left. But I think it's fascinating to think that the snow that melts on the left-hand side of this sign might melt and go downhill all the way to the Atlantic Ocean, and the snow over on the right-hand side, when it melts, it's going to go all the way to the Pacific Ocean. That's called the Continental Divide because this line is actually dividing all the water of North America in two. I see that it looks like there might be some more questions in the Q&A box. So I'm going to go look at those really quick. Ananya asks, why are the lines colored differently? Oh, on that map of the divide lines, let me go back to that really quick. They're colored differently just to help you see it. Yeah, these lines are not rivers. These are the dividing lines that show you which direction water is going to flow downhill. The big red line is the Continental Divide. That it's just saying that water on the left-hand side of that line is going to go to the Pacific. Water on the right-hand side of it is going to go somewhere else, like the Gulf of Mexico. They're not rivers. That's just the line. There's nothing there in real life, except for maybe the tops of mountains. It's like a line of mountains, basically, that just shows which way the water is going to flow. Natalie asks, does this mean I could have touched the same drop of water more than once? Definitely. It might, there would be no way to tell, probably. Yeah, Ananya says, I'm talking about another slide where the lines have the color of the rainbows. Yes, this, I think this is the slide that Ananya was asking about. But yes, this slide is showing just, these are the dividing lines that show which way the water flows downhill. But yes, Natalie, it'd be probably impossible to tell if you've ever touched the same raindrop twice, but it's certainly possible. All right, so moving on. There are a few exceptions. This one might be a little bit tough to see, but this is a river in Wyoming that it's coming from the top part of the map. And right here in the middle, you'll see the words parting of the waters. This is actually a place in Wyoming where a stream actually breaks into two streams, and this one on the right is called Atlantic Creek because this creek water will flow all the way to the Atlantic Ocean, and this left one is called Pacific Creek because it's actually that right there. It's a dividing line that I think it's really funny to think of maybe like a couple of fish and their buddies, and one fish goes into one creek and the other fish goes into another creek, and they are going to end up in two different oceans. It's actually a place where the water divides in two, and right at the Continental Divide, it goes in two different places. And this is a bigger picture of that Great Basin. This is that section of Oregon, a little bit of Idaho, a lot of Utah, most of Nevada, and a good chunk of California here, even extending down into a little bit of Mexico. And this is where it's basically, it's like a bowl. A basin is kind of like a big tub or bowl. And what you'll notice is up on the upper left-hand side, the Cascade Range, that's part of the rim of the bowl. The Sierra Nevada are a range of mountains. Over here on the right, there's the Rocky Mountains. All of these mountains are acting like the edges of a bowl or a tub, and any water that falls in this area, there's just no way for it to get to the ocean. It's trying to roll downhill, but all the rolling downhill ends up in this big, bowl-shaped area here. The Great Salt Lake in Utah, for example, that water doesn't go anywhere. Water rolls downhill to the Great Salt Lake, and then it never keeps on rolling onto the sea. It's one reason I think there are a lot of mineral salts there, but as water evaporates over time, the lake just gets saltier, I believe. There's, the rest of our rivers usually are fresh water after you purify it to make sure there's no bugs or, microorganisms in it. You can drink fresh water because it falls out of the sky as just pure water, and then it's flowing over the top of the earth. It's not like the ocean water or the Great Salt Lake water where it's actually kind of salty. You don't want to drink it. All right, so I have an activity for all you guys. In another tab of your internet browser, after I show you what I want you to do, you'll just have to listen to me because I want you to open up Google Maps in another tab. And what I want you to do is you are going to open up Google Maps, and then I want you to find, starting at your home or any other location you'd like, I want you to try to trace the closest stream or river all the way to the ocean. So we are actually going to find out how water makes it to the sea. I'm going to open up my own Google Maps to show all of you. Okay, so you can go to google.com/maps or maps.google.com, and this is what you'll see. The Delphian School is in Sheridan, Oregon. So I'm going to zoom out here a little bit so you guys can see all of that. If you've watched our previous webinars, you probably already know that. But yeah, I'm going to zoom out here, and you can see this is Oregon in the western United States. Here we are outside of Sheridan. So in your own internet browser, open up another tab, and we are going to, you can do whatever you want, by the way. You could do your house, you could do a famous location, you could do a school, you could do a mall, a movie theater, whatever you want. Just find a location and try to find the nearest stream. For me here at the Delphian School, over the right, this is Rock Creek, and you'll see it labeled here, Rock Creek. If you guys have any questions about that, just ask me in the Q&A box, and I'll try to help you with that. Natalie, we are going till 11:45. Great. Looks like there's no questions about Google Maps so far, but if you guys do have any, just let me know. Okay, so Rock Creek here flows southward, and it joins the South Yamhill River here in Sheridan. And you'll see this, the roads are usually, they go pretty straight, but the river curves a lot. It goes back and forth. The reason any river curves like this is because it's trying to find the easiest route downhill. It's just the line of any creek or river or stream is the line of the land descending. So if you wanted to know what's a higher elevation, like what's higher up in the air, the left part of Sheridan or the right part of Sheridan? Well, the answer is the left part of Sheridan is higher up in the air because the South Yamhill River here flows from west to east. It's going to the east, so we know that east is downhill. If you were ever like lost in the wilderness and you found like a stream or a creek, one way that people usually recommend that you could try to get out of the wilderness and save yourself is you find a stream or a creek or something and you follow it downhill. Because if you follow it downhill, it'll eventually join other streams or creeks and then rivers, and they'll all join together hopefully. And hopefully you'll find a town or something eventually. Okay, so I'm gonna keep on following South Yamhill River to the right. You'll see it seems like it's getting at times a little bit bigger, very windy. It goes all the way up here to, look at all these curves, look at all these bends. This is actually the water finding the best route downhill. Now, after going north and east for a while, it kind of doubles back and it goes to the west and it ends up going through McMinnville, a little town close to us. Nice little city. It keeps on going around back and forth. It goes by the Evergreen Aviation Museum. That's a cool place. Keeps on winding, goes past other little towns. We're gonna zoom out here a little bit. But eventually, you'll see it connects up to a bigger river, the Willamette River. The Willamette River is a bigger river that goes mostly north-south in Oregon. You'll see down here, well, if we zoomed in, the Willamette River goes way down south, much further than us. It goes, you'll see there's the Willamette River some more. It hits most of the big cities of Oregon. And we'll talk about that a little bit more a little bit later. But if we keep on following the South Yamhill River that went past the school, it eventually joins up with the Willamette. And if we keep on following the Willamette River, it keeps on going downhill and it keeps on getting a little bit bigger, a little bit bigger. And you'll see more creeks and more streams are emptying into it. Until now, the Willamette River is getting really big. More things are still joining it. And we get up here to Portland. That's Oregon's biggest city. And now the river is pretty big at this point. There's Oregon Museum of Science and Industry called OMSI. Here, the Willamette River is bigger than several city blocks. Each one of these squares here, of course, is a whole big, businesses and, big buildings. But the river, it's bigger than any of them. The river's giant at this point, but it keeps on flowing north. The Willamette River is still trying to go downhill. It's still trying to find its way to the lowest point it can. And that means joining together with an even bigger river, the Columbia River. This is that giant big river that makes most of the northern border of Oregon. The Columbia travels from east to west. Here, the Willamette empties into it, and they keep on traveling north. More rivers, more streams empty into it. The Columbia gets just bigger and bigger until finally, giant and wide. Look how big the Columbia River is here. This is bigger than the cities next to it. It finally empties into the Pacific Ocean. So a drop of water that falls down here in Sheridan or at the school, winds its way downhill further and further and further until it gets to the South Yamhill, then the Willamette, and then to the Columbia, and then it goes all the way to the Pacific Ocean. And there, it might heat up, evaporate, and rain on us again, and be part of that water cycle. So I hope that's interesting to all of you. Did anybody trace water near themselves? If you did, I'd love to hear about it in the Q&A box. Benjamin says, cool. I hope that's in relation to following a stream or a river near your home or somewhere. Yeah, if anybody else was able to follow a stream or river next to them. Oh, Alette says, I tried to follow Kern River in California to a river, but it emptied into a lake. All right, well, that's awesome, Alette. Maybe that lake has another river or stream coming out of it. Maybe it empties somewhere else. After the class, I find maps fascinating, and I recommend that you spend a little bit of time looking over the map and see if you can figure out how that raindrop eventually gets to an ocean. Oh, Alette says, I meant to an ocean. Oh, so it sounds like it did get all the way to the ocean. That's awesome. I hope I'm saying your name right. Ilionis? Ilionis says, what if it disappeared into small streams and it sort of disappears? If the stream that you're following disappeared, you were probably actually going the wrong direction. And that's fine. If you're following a stream and it gets smaller and smaller, that means you're actually going upstream, you're going uphill. I would go back to that same spot where it seemed like it was starting to disappear, and I would go the other way. As water moves downhill and combines with other water, you will find the streams getting bigger and bigger. So, okay, good. While you guys work on that, I'm gonna keep on talking about rivers a little bit. These are the Great Plains. This is a big section of the middle of the United States. And if you were trying to get from one place to another across this part of the country, it wouldn't be too hard. There's big open grasslands. You could ride a horse across this or a wagon. It wouldn't be too tough. But what if you were trying to travel through a part of the country that looked like this? There's dense forests. You can see just a little bit of water there. There's mountains. If you're trying to cross part of a country like this, back in the day, there wouldn't be any roads. No roads to follow. So what would you do? The Native Americans across the United States, these are, I believe, Chinook. These are the Chinook that live in the Pacific Northwest and still do. They are showing here canoes. Rivers, while there are waterfalls and there are rocky parts of rivers, rivers are often the flattest route through any section of wilderness. Canoes and other boats could thus be the best form of transportation through a section of the country. If you're trying to get from one place to another before there were roads like this was probably your best way to get around. A long time ago now, I think about a little bit more than 200 years ago, Louisiana basically was trying to control this middle portion of the country that they called Louisiana. France basically couldn't control it anymore and decided to say to the United States, hey, look, we're going to give up our claims to the middle part of the country. You can take it over if you pay us. And the United States did. And that was called the Louisiana Purchase. You may have heard about this when studying history. Well, after this happened, the president at the time, Thomas Jefferson, decided that he wanted to have people from the United States explore this whole area. Because there were not roads through this whole section of North America, he had a group of people, Lewis and Clark, explore it. He sent them out with a big group. They were going to be gone for a few years. but they knew that to travel across the country, they would have to travel by boat, by canoe, because that was the highway of the time. Starting out here in Pittsburgh, they traveled down the Ohio River and then up to St. Louis. Then they traveled up the Missouri River as far as they could go. They had to cross the Rocky Mountains, which I've read was a bit of a surprise. For some reason, they didn't have good enough information about what was there. I think the Rocky Mountains were a bit of an obstacle. They thought they could just kind of walk from one river to another and keep on going, but they had some mountains to cross. They made their way through, what's now Idaho, and they eventually made it up to other rivers here, like the Columbia River, and were able to travel all the way to the Pacific Ocean. But a journey like this would have been incredibly difficult at the time if they had not had rivers to travel across. They had this boat built that was called a keel boat. It was kind of a flat bottom boat that all of the people of their party could fit on. And they would use, it had a sail, but they would also use poles, and they would kind of push themselves along up the river. Because when you're going upriver, the water is flowing against you and it can be difficult to move. So they would use these long poles to push themselves. Later on, steamships were built and people could travel up and down these rivers using steam engines on boats. This big wheel in the back here would turn with a steam engine pushing it, and people could travel like up and down the Mississippi River, up and down the other big rivers. And before there were ever good overland roads to move things up and down, people and goods, things that were being bought and sold, would travel on boats. And they still are used. This is a modern picture of the Mississippi River, the biggest river in the United States. And down here we see a boat pushing a whole bunch of barges. I'm not sure what's on these barges, but it could be it could be farm goods. It could be things that were manufactured further up the river that are now moving down the river to a port, so giant ocean ships can take it. But look how much stuff this one boat is pushing. I think that would take a huge number of semi-trucks to push or to move that same amount of stuff. So rivers are still used today to move things. This is a picture of the Columbia River. This is a whole bunch of logs. You can see a little person walking across the top of one of those logs. But trees are like a crop. They're almost like a farm crop in Oregon in the Pacific Northwest. They're chopped down and they're sent to be turned into wood for building things, to be turned into paper, lots of other uses. But these logs are moving down the Columbia River to the ocean. Maybe they're being sold to a different country. Maybe they're going to move down the coast to California or somewhere else. But the ocean, again, is like a giant highway for all of this stuff moving around. Just think about how many trucks or trains would have to move this much stuff. It can be a lot easier to move across the rivers. So we're about out of time. So I'm going to leave you with an activity that you can do after class today. The last thing I want you to think about is I want you to think of several big cities in your state or country. And then I want you to look on Google Maps and find out if they're located on a river. So in Oregon, for example, we just saw that Portland is divided by a river. The city of Portland was built all around two big rivers. What about the big cities in your state or country? Are they also on rivers? Are they near a river? And let's think about this. This will be like your homework for next week. Think about, why would big cities so often be on the ocean or be on a river? And does it have anything to do with some of the topics that we've talked about today? Thank you guys for watching. That's all the time we have for today. After lunch at 1:15, Quinn will be teaching computer science. There's still time to tell a friend or tell a family member. Talk about the webinars. We love all you guys watching. We love all your questions. We have the next 3 weeks of classes are already posted. So tell some friends, get more people registered, because we like big classes. We love answering your questions. I will see all of you next time. Bye.